In this video, we're going to discuss frequency distributions, more specifically a categorical frequency distribution. To start off this, I'd like to just discuss the situation. We have a researcher who likes to play a game on his smartphone, and he's going to play for 2 hours. The objective of this game is to collect as many of the virtual characters as possible, and here's what the researcher got for that 2 hour of playing time. This is all of the data. Your original data that you collect has a name for itself, and it is called the raw data. Okay, so raw data in its original form. It's not categorized yet. We haven't really maybe organized it in a way so that it's better for us to understand, so that's what we call it, raw data. What we do with that raw data is that we're going to throw it into what we call a frequency distribution. We're going to organize that data using classes. We're also going to organize it with using the frequencies from the data that we've collected. So what is a class? A class is called the quantitative, or it could be the qualitative categories that the raw data is placed in. Remember, quantitative has numerical values. Qualitative has some particular type of quality that goes for that data point. The next thing is, what are frequencies? Frequencies is the number of times that data value occurs within that particular class. And we will go and then now make what we call a categorical frequency distribution. So what a categorical frequency distribution is used for, it's to describe nominal or ordinal levels of data. And just a reminder, nominal means that each class doesn't have ranking over one or another. There isn't a defined definition of one better than the other. Whereas ordinal, yes, maybe there are different levels to it, but there's not a clear-cut interval between those particular classes. Okay, so now let's go into how do we construct a frequency distribution for this particular categorical example that we have. There are 4 steps that we're going to look at. First step is we're going to make a table with the following headings. We're going to, in this order too, we're going to go class, tally, frequency, and then we're going to have percent at the end. Step 2, tally up all of the data points. Step 3, let's record those frequencies. And then finally, step 4, we'll calculate the percentages of that particular research. So here I brought up the data points again, the raw data from our original 2-hour study for the researcher. There's all the characters that he was supposed to collect, or that he did collect. And well, here is our table. Well, we need to have our classes. So we say, what are all the different characters that could have been collected? Well, we look at here, we have plastic, we have wheat, we have insect, we have metal, and there are liquid. That's all of the different classes. Now we go through and we would calculate, or just tally up and count, how many times did we collect plastic? Look at it, we do our tally marks. We have 9, it looks like. And then we go through and find wheat. We have 7. Then insect, we have 12. Then metal, there are 2. And then finally liquid, we have 5. And then we just take all the tally points and then we write a numerical value for the frequencies. So we have 9, 7, 12, 2, and 5 again. And then the last thing that we'll do for a categorical frequency is that we'll calculate the percent. Well, we add up all of our frequencies here. So we're going to take 9, 7, 12, 2, and 5 and add that up. Comes out to give you a value of 35. And to calculate a percent, we take 9 from plastic divided by the 35 that are total, times it by 100, and it turns out that 20% or 26% of the characters that were collected were plastic. Do this again for wheat. We would do 7 divided by 35 and times that by 100, which gives us 20%. Insects would be 34%. Metal would be 6%. And then liquid would be 14%. So what we found out by doing this categorical frequency distribution is that from the data, the most popular character that was captured happened to be the insect at 34% of the time. So there's how you can construct a categorical frequency distribution.